11.3 goes over properties of logarithms. What we're going to start with is when we are working with the natural log and e, as well as a base raised to the power of log with the same number as its base. So when you are multiplying the natural log by e, like you are in example 1a, they actually cancel each other out because they're inverses of one another, and the only thing that you have left is that power. So in example a, that ln times e to the power x, that ln and that e cancel out, and you're just left with x. It's the same thing as if e is raised to the power of ln times something. So if e is raised to the power of ln times something, the e and the ln will cancel, and you're just left with that number that should be multiplied by the natural log. For example B, you have 2 to the power of log 2, 8. The 2 of the base for the log as well as the base of the number that's being raised to a power are the same. When that happens, they cancel each other out, and you're just left with what's left over, which in this case is 8. For example 2, we're writing each expression now as a single logarithm. When we're working with addition of logs, it represents multiplication. So as long as there's a plus sign between 2 logs or 2 natural logs with the same bases, you can keep the log of that base and multiply the whole numbers, as long as, again, there's addition between the two. So if we look at example 2a, we have log 2 of 7 plus log 2 of 5. The log 2 is the same on both sides, so we're going to keep that, and we're going to multiply the 7 and the 5. So 7 times 5 is 35, so this is just log 2 of 35. For example B, we have natural log square root 2 plus natural log square root 3. This natural log is the same on both sides of that equal sign. So we're going to keep the natural log, and we're going to multiply the square root of 2 times the square root of 3. You have the same index for both of those radicals, so multiply what's underneath them, keep them underneath the radical. So we just have the natural log of the square root of 6. Next, we're going to work with subtraction. If addition represents multiplication, subtraction will represent the opposite of multiplication, which is division. So we're going to deal with the same thing here. If our base is the same for both of the logs that are being subtracted, we're going to keep that part and then divide the whole numbers. So for example 3a, we have log 2 of 3 minus log 2 of 7. So you're going to keep the log 2, and you're going to divide 3 by 7. Now, when you can't divide them like this, you just write it as a fraction, so it's going to be log 2 of 3/7. For example B, we have the natural log w to the 8th power minus the natural log w squared. Now with this one, you have that natural log on both parts. So you're going to keep the natural log, and you're going to divide the w to the 8th power by the w squared. Remember, when you have a base raised to a power and you are dividing them, you are subtracting those powers if the base is the same. So this is just going to be the natural log of w to the 8th power minus the 2nd power, which is the natural log of w to the 6th power. For example 4, we're rewriting these in the terms of log 2, which means we want the whole thing to be centered around that log 2. So when we look at example A, we have log 2 to the power of 10. Now, when you have a log with a base raised to the power of 10, that power has to go in front of that log. So this is going to be 10 times log 2. This is your answer for this one. For example B, you have log square root 2. So this 2 that's underneath the radical, remember the radical represents a power of 1/2. It's the same thing as saying log 2 to the power of 1/2. Again, we have an exponent on that big number. We can't leave that there, so it has to go in front and multiply with that log. So it's going to be 1/2 times log 2. For example C, we have log 1/2. So this 1/2 is represented or representing the same thing as 2 to the negative first power. So because that power is there, we're going to bring it to the front, and we have -1 times log 2, which is the same exact thing as just the opposite of log 2. For our next set of example, we're working with log 2 and or log 3. So if we look at example A, we have log 6. You got to think to yourself, 6 is the same thing as what? As a 2 and a 3. Well, if we multiply 2 times 3, that gives us 6. So if that's the case, this is the same exact thing as saying log 2 times 3. Work backwards from here, just like we did prior to this within this lesson. If you have multiplication, it also represents addition. So if that's the case, this is the same exact thing as saying log 2 plus log 3. For example B, we have log 16. Well, we have to write this as log 2 to a power of something, 2 times something, 2 plus something, or log 3 to a power of something times something plus something minus something. So if that's the case, you know that 4 to the second power is 16. That's not 2 to a power. But if we take 2 and raise it to the 4th power, it's the same thing as log 16. So that's going to give us log 2 to the 4th power. Once again, we have an exponent there. It has to be brought to the front. So we're just going to move it to the front to give us 4 times log 2. For example C, you have log 9 over 2. Remember, division is the same thing, fractions are the same thing as division. So this is also log 9 divided by 2. Think to yourself, what represents division? Subtraction. So this is also the same as log 9 minus log 2. We need to change that log 9 into 2 to the power of something or 3 to the power of something. 9 is 3 to the power of 2, so this is also log 3 squared minus log 2. You cannot keep an exponent on a log, so bring it in front. So it's going to be 2 times log 3 minus log 2. For example D, we have log 1/3. Remember, 1/3 is the same thing as 3 to the negative first power. So this is the same as saying log 3 to the negative first. We have an exponent on there that we need to bring to the front. So we're going to have the opposite of log 3. For example 6, we're rewriting each expression as a sum or difference of multiples of logarithms. So for example A, we have log xz divided by y. If you remember, division means subtraction. So if we rewrite this, we would just have log xy, or xz, minus log y. And then you have multiplication here. Multiplication is the same thing as addition. So this is going to be log x plus log z minus log y. And you see that I put parentheses around the log x plus log z to represent that that's what was in our numerator to begin with. So if that's the case, you want to make sure that you use parentheses or brackets with these to represent the specific operation that's going first within all of the operations. For example, B, we have log 3 of x minus 3 raised to the 2/3 power all over the square root of x. So we have division here happening because we have that fraction. So I'm going to rewrite this first as subtraction. So we have log 3 of x minus 3 raised to the 2/3 power minus log square root x, log 3 square root x. from here, if I work with the left side, that 2/3 cannot be in the power, so we got to bring it out front. So we're going to have 2/3 times log 3 of x minus 3 minus log 3 of the square root of x. Now that square root of x is also x to the 1/2 power. So this is going to also be 2/3 times log 3 of x minus 3 minus log 3 of x to the 1/2 power. Again, you cannot have a power, so bring that out front of that one log that has the x by itself. So we have 2/3 times log 3 of x minus 3 minus 1/2 times log 3 of x. For our last example, we're still just rewriting each expression as a single logarithm. For example A, we have 1/2 log x minus 2 times log x plus 1. So we're going to work part by part with this. We have 1/2 log x minus 2. This 1/2 is going to be the power that is on that x. But we have that minus 2 there. It's kind of trying to confuse you a little bit because of that minus 2 outside the parentheses on that x. So what you want to do is you want to take that 1/2, you want to put it on the power of what's attached to the log. The only part of this that's attached to the log right now is the x, not that minus 2. If the minus 2 was attached to the log, you'd have parentheses on the x and behind the 2. So that those parentheses are only on that x. They only surround the x, so that 1/2 only applies as the power to the x. So we're just going to rewrite this side as log x to the 1/2 minus 2. You know that the power of 1/2 represents the square root. So this is the same exact thing as saying log square root x minus 2. You got this side taken care of. Look at the other side. The other side gives you log x plus 1. There's nothing being multiplied by the log, so there's no power on that set of parentheses. You don't have to simplify anything with the log on the right side of that multiplication sign. Multiplication represents addition. Because multiplication represents addition, you can say that this is the same exact thing as log square root x minus 2, you can put that in parentheses if you'd like, plus x plus 1. From here, you can combine like terms once you get rid of those parentheses. So it's just log square root x minus 2 plus x plus 1. Your like terms are the -2 and the 1. So we can rewrite this as log square root x plus x minus 1. For example B, we have 3 times log y plus 1/2 log z minus log x. We're going to work 3 different parts with this. There's 3 separate parts, so we're going to work with each of them individually first. The first part we're going to look at is the part all the way to the left. You have 3 times log y. We said that that 3 in front was brought there because it was a power on a term. So that power goes to what's attached to the log, which in this case is y. So this is going to turn into log y cubed. You can't do anything else with this, so leave it alone. Move to the next term. You have 1/2 log z. That 1/2 is going to become the power on the z, so that's going to give you log z to the 1/2 power. We keep saying that the 1/2 power is the same thing as the square root, so this is log z under the square root sign, so the log of the square root of z. Next, you have a negative log x. Because you have that negative log x, you can't do anything with that. So you can't do anything with that, so you can just drop it down. Now, when you go to rewrite this, this is going to give you log y cubed plus log square root z minus log x. We keep saying that addition means multiplication, subtraction means addition, or sorry, subtraction means division. So, addition, multiplication. Multiply the y cubed and the square root of z. Keep the log. That's going to give you log y cubed square root z. You also have minus log x. We said minus means division, so keep the log, divide your y cubed square root z by x. You cannot do anything else with this, so you just have the log y cubed square root z over x.